tonight we're going to create a 2D visioning, single view visioning process, and to actually pick apart this time. So, over the last few weeks, we've been, I've broken it down, and we've been practicing like components of this. And then tonight, so we're going to put it like all together and create a pick program so that we can set apart in a random place within the field of view of the camera, and have the robot go and pick it and put it somewhere. All right, so that's the goal for tonight. So just to kind of recap what we've done so far. So we've created a camera calibration. So everybody remember how we did that. Then we created a simple 2D visioning process so that we could just have the robot camera find an object, identify it, and be able to tell the difference between that part and some other parts that might be in the view. So so we've done that. And then Tuesday, we talked about the instructions that we're going to have to add to our Teach Pendant program in order to utilize iRVision and incorporate that into our visioning process. So remember that we created a camera calibration, and in the steps in that we had to select the appropriate calibration grid. So what do I mean by that? An appropriate calibration grid. Remember what we might have had to think about when we did that?
Using the appropriate size for like the circles and stuff like that, and making sure there's nothing that would cause it to improperly calibrate, such as let's say a quarter around the same size as the middle circles that defines whether it's moving an X or Y axis.
Yeah, so so we did have to select a grid though that, like you said, that an appropriate one as far as the size goes. I mean, we want a calibration grid that fills up as much of the field of vision as possible. So in our case, we were able to use a calibration grid in which the dots were on 30 millimeter centers. Okay, and then we had to position the grid within, under the field of view, of course. And then we had to teach a user frame on the grid points, on that calibration grid. And then we went into the iRVision tools, and we created a calibration based on that calibration grid that was known and not moved. So why were we doing that one step, the calibration step? How would that actually help us in creating a 2D iRVision process? Yeah, good stuff.
Because you can teach the camera what it's actually looking at in a way. Like you can teach it like this far apart equals this much distance.
Okay, so that's one important thing. We want to be able to establish distance, and so that the camera can calibrate how many pixels really are, represent, say, a millimeter. So, the camera has a sensor in the back, made up of pixels, and what the iRVision did is when it looked at that calibration grid and knew that the dots were on 30 millimeter centers, then it established how many pixels there were between dots, and then it establishes a relationship of a ratio between pixels and millimeters. Okay, so that was one important reason. What was the other? So one was established distance.
The other one establishing orientation to where it's actually at.
Orientation to the robot. So, when we taught and that was the important thing. So when we taught the calibration grid, we had to use a tool that had a known center point, a taught center point. So we had a tool frame for that tool. And then we taught, we put the calibration grid in front of the robot, and we taught it where it was basically by moving that pointer, that tool, to the appropriate dots. And then the robot knew, like, it knew where that calibration grid was in relationship to its own world coordinate system. Then when we took a picture of it, it was able then to reconcile the two, what it was looking at and what it knew that position of that grid was. And so, so that was an important step in the calibration. Now that's, the camera now is calibrated unless it gets moved or something else happens, but now the camera is calibrated, and when we create 2D vision processes afterwards, we'll base it on that calibration unless we feel something's wrong with that calibration, and then we'd have to recalibrate the camera. Okay, so so that was one thing. Then on Tuesday we talked about some of the things, some of the changes that we were going to have to make to our program, some of the instructions that we'd have to incorporate. And so one of them was a vision command to just run that process that we're going to develop in iRVision for finding our part, whatever that part might be. And then the second one, once it's run the process, then it's going to create an offset. So if our part that we taught was unmoved, then the offset is really going to be 0 because it's in the same place it was taught. But if the object is now moved, our part's now moved to a different location, then we're going to see an offset get thrown into the vision register. So, and then that's going to be used as our vision register offset. So what's a vision register? Girma.
The vision register is with the camera look at the object at teach position.
Yeah, but the offset itself is going to be just like a position register offset. So it's like a position register, but it's for vision. And so you know how you modified your teach-pendant programs with a position register offset, right? To move, and you had a whole bunch of them you used for your project. So it could be an X and Y or Z.
Right.
So the vision register is doing this offset. It's going to do the same thing. A value is going to be put in there, and but it's not going to use Z. It's just going to use. Remember we talked about it's just going to be X, Y, and then R. So rotation around Z. Okay, and then in our program, later in our program, when we go to pick that part, first we're going to teach it where that part is. We'll teach in the teach pendant. We'll teach it where that part is. But when we run the process, it's going to, at this point, it's going to consider that offset when it goes to pick up that part. So if it's been moved into a new location, that's going to update the offset, and then when it calls up that offset to go pick it, it's going to move. It's going to change the orientation of the grippers and the location on the grid to pick up that part. All right. So that takes us to tonight. And so I'm gonna go through the steps here in RoboGuide. You can follow along in the FANUC textbooks for 2D visioning. So this is going to be in chapter 13 and starting on page 1314 in your books. So you don't have to, but if you want to follow along, you are welcome to. But I'm going to go through this step by step. And okay, so I have a part on the table. I already have a calibration established for this camera, and it's a fixed camera, just like the fixed camera sort of like the fixed camera that we're going to be using on tonight when I do the demonstration on the actual robot. So here's the program. But we're going to go in and then we're going to create a 2D single view process to use in this program. So you can see that okay. So I'm going to go to iRVision and Vision Setup. And let me expand this up a little bit. So first of all, we need to select a V type or visioning type. And we're going to select Vision Process Tools. We're going to create one. So we're going to hit Create. And then we're going to leave it at 2D single view vision process. And so we have to give it a name. So I'll just call this kickball. All right, so I give it a name. And then I'm going to edit that process. And so right now, let me make this a little bigger. So right now, one of the first things we're going to answer here is which camera calibration we're going to use. So I'm going to use this class calibration 2. It's one that I know has been done recently. Here we can change the exposure time if we have to. So you know how when we did that process last week, we had to up the exposure time to get a good snap of that picture of the part. Because I'm in RoboGuide, I really don't need to do that. The other thing we'll do on this page before we go to the GPM locator tool is we're going to change the user frame. So the user frame here is not the user frame necessarily that we use to calibrate the camera, unless they are the same. But the user frame here is the user frame that we're going to use in our process. So when I taught that pick program on the robot, I was using user frame 0. So I'm going to use user frame 0 here as well. So this isn't when I calibrated the camera here, I used user frame 9. That was all calibration. Now we're talking about the user frame that we're using in this process. So that's an important distinction. Okay, that's the only thing that I'm really going to do here. So there are some other options. Oh yeah, we're going to leave that at fixed frame offset. There's some other options that you can look at and investigate that's listed. They're all described in chapter 13 in your books, but for right now, I'm just going to keep this simple. This is really all we need to do on this page. We're going to come back to this page in a moment, but we're going to go to the geometric pattern match locator tool, so the GPM tool. And let me just zoom in on this a little bit more. Okay, and then so the first thing to do is to teach the part. And so this brings up that little window there, that's like the field of interest. And what we got to do is we got to shrink down that window so that we really just are capturing our part. We don't want anything else, any other distractions in here. We just want our part. And we don't want to make it too tight, but just kind of close around it. And then we're going to okay that. So it looks like it picked it up. I almost cut off a little bit here. I'm not really that worried about it. It's pretty close. And then remember, last week we talked about how we could use the masking tools. I'm not going to mask. There's not going to be anything I really want to mask on this part now, but I could, but I'm not going to. I'm going to leave this alone. I'm going to up this threshold. It's not really important here, but it's going to help us when we're out there when we do this on the actual robot. I'm just going to increase that threshold up to like 90% so it doesn't find things I want it to ignore things that are maybe close but aren't the object I'm looking for. So I'll up that to 90%. And then I'm going to do a snap and find. So on our, so it found what I needed to find. It gave it a center. I could change that center if I wanted to. It's just not important. It's not really important here, so I'm just going to leave it there. And that's all I needed to do here. I found it just fine. I got a score of 100, which doesn't surprise me, being that this is RoboGuide. So I've done everything I need to do on this page. I'm going to go back to the single view vision process page, and there's one more critical thing that I have to do here, and that's to set the reference status for this part. And this location, this reference position is going to be used later on by the iRVision instruction, where it's going to establish an offset for our part and put it into the vision register. So we're going to go ahead and first we're going to have to snap and find this part again. So it found it, and then now for the reference position status, I'm just going to set it. and that's established. So this is really where this part is in relationship to the, don't really need to worry about any of that. All right, so we can save this. It's important to save your process, and we can exit. So this is all we need to do, and now we have a process called clone. So I'm going to go back to iRVision. I'm going to go back to my robot, and I'm going to look at this program. And there's going to be a couple of changes I need to make this, because when I first set up this process, I was using a different vision process, so I'm going to change create. So I'm going to, I went to the vision run statement, and then defined, I have to tell it find to use that process that I just worked out. So it's a pick bone. Same thing here. Go get offset, and then I'm going to put pick bone again. And it's as you can see, it's putting the information in Vision Register 1. Okay, so I'm gonna change my display here. I'm just gonna make it double, and over here I'm gonna put I'm gonna bring up the Vision Register page. Detail of that. I know this is maybe a little hard to see. Well, you can see it okay. All right. So, all right. So I've got that done. Now I have to in this program, it's going to go down. It's going to, after it finds the offset, it's going to go to the pick point using that offset. So I'm going to go to that pick point right now. Where I'm going to bring this robot down there. So. Okay, so now I need to teach that, I need to touch up that position. So I gotta make sure I'm in the world. So I'll go to the coordinate system, in the world, I'm gonna move this down, and then I'm gonna rotate those workers too fast. Let's get them facing the correct way. Then I'm going to take a look at the straight on, and make sure those workers look all right. They look all right, a little more. Close enough. And then I'm going to center it in Y. So I'm going to switch my coordinate system to the world, and move it over in Y. Fast. Look at it in the right view. And I'm going to move it next. So now I'm going to touch up that pickup point. So I'm going to have my shift key and touch up. And I'm going to select that nice and adjust. Go back to the beginning of the program, and we'll run that process. So, from the beginning, we're in step, and go forward. So it's going to go to its home position first. Position. So get the offset, update the offset, and then I'm going to pick up the part, and it's just above the part, and it's going to pick up the part, and we'll just have to close the grippers on that, and wait a couple of seconds, and it's gonna go back up. And then, it's gonna go to some drop-off point, open the jaws, and then go back on. Okay, whew. So, now what I'm gonna do is, so let's run that without step. So we'll just back out a little bit on this, we'll just run this slowly. And so there it goes, picks up the part, moves it to some location. Yes?
Okay, so I still having a hard time understanding how on line 8 of the program, it says vision, get offset, and then it calls on the program, which is what, pig bone, right?
In my program, yes, big one.
Vision register to jump to label 99. So what I'm understanding is on that line is telling the robot that if there's no offset to jump to label 99.
If it can't find the part, it's
Okay.
gonna jump to 99, which is the end
Okay.
of the program, which means it won't continue 99.
Okay.
Okay, no, good question. All right, so then I'm gonna just modify that part on the table. And I'm gonna move it to, so here's that part. And maybe I'm just gonna turn it a little bit and maybe move it in X a little bit. Oops. It's too far. And maybe a little bit in the Y-axis. All right, and then we'll just run that process again. And so we can watch these offsets. So they were 0 because, well, when we first ran it, it was in the same position we taught it. But I'm going to move into step now, and so that we can see as we go forward, when it sees runs the process, and then updates the vision register. So we got an R, so 22 degrees in R, and then we have a change in Y and X. Okay, so I'm going to take off step again. And then so now the grippers are going to orient to the part position, the change part position, pick it, and then do its thing. Okay, so that's what we're going to do back there on that robot. We're going to do the same thing.